Welcome to ESI Does It, the third-party development presentation for Fanfest 2017. I'm CCP Bartender, and I'm joined on stage by CCP Snowden. And today we're going to be talking about the development journey of ESI and how it works under the hood, and about our plans for the immediate future. And I'm also apparently going to be swapping between ESI and ESI throughout the whole presentation, so good luck. But before we do that, I want to introduce the team that made it and talk a little bit about the history of third-party development so we can have some context on why we created ESI in the first place. So this is Team TechCo. I'm not going to read out all the names. We are a force multiplier team, so our job is to try and make the lives of all the other development teams in CCP easier. And we're also, to a certain extent, a core technology team. So we sometimes deal with foundational parts of the EVE code that touch many, many game features simultaneously, stuff like the logging code or the database code. So we do a ton of outreach to other teams, and we work very closely with a bunch of people all over the company. And to give you a bit more of an idea of what our day-to-day is, some of the big tasks that we've got on our roadmap for the moment are an overhaul of EVE's build and test system. We are moving Paparazzi, which is the tool that makes these renderers. We are moving that from virtual machines in our data center into the cloud. We're upgrading the in-game search from using the Sphinx search engine to using the Elasticsearch search engine. And we have a bunch of ongoing maintenance work involving keeping the DB performing as best it can and keeping our Perforce depots sane and updating our Perforce workflows. But on top of that, and the stuff that you guys are all interested in, we are also responsible for most of the third-party development stuff. So we maintain the static data export, we maintain the XML API and CREST, and we are in the process of developing ESI. I want to take this opportunity to let you guys know we actually don't own the developer's website or the SSO, but we can totally be a point of contact for those if you need to talk to us about them. Before we go any further, I want to acknowledge some people who are probably not in the room today, but who had an outsized impact on your development experience over the last 12 or so months. I want to recognize CCP Fox4 for his exceptional stewardship of CREST and for his input on the original back-end design of ESI. I want to acknowledge CCP Telus, who was instrumental in the first push to get all the endpoints on ESI that you all saw on release day out the door, and CCP Avalon, who's incredibly patient about letting me pester him about the development website whenever there's a problem. So this is a timeline of what I consider to be the first significant chunk of third-party development history in EVE. This timeline's actually pretty approximate. It turns out no one was chronicling this stuff properly, so a lot of these dates are pulled out of like blogs and Git commits, and in one case, the Wayback Machine. But we have a whole bunch of things along here that really set precedents for third-party development in EVE. It starts with the static data export. This possibly existed since beta, but I can't confirm that. It definitely existed in 2006 though, because at this point we have a blog telling us that there's a second version of it coming out for Red Moon Rising. It's an MS SQL, my apologies, database dump that's been heavily filtered to remove any sensitive data. I don't know how widely it was used at this point. There were probably some early mapping tools and some early skill planning tools that existed based off the static data export. But the real flashpoint for third-party development is this website called MyEve and EveMon. I don't know how many of you remember MyEve, but it was a web portal that existed, and you could go and log into it, and it would give you kind of textual data about, you know, what skills your character had and that sort of thing. And it was pretty much as soon as it was released, EveMon started ingesting data from it and using it to build the skill planning that we're all familiar with. So around about this point, a chap by the name of CCP Garthak enters the picture. Garthak has just come from another company where he's just finished implementing an XML API, and he sees this, and it's causing what he described to me as database sadness. So he's keen to alleviate that, and so in May 2007, the XML API is announced, and that's pretty significant because now we've got a place to put data that we wouldn't want to put on a public portal. Stuff like the map statistics would be impossible for a human to read, but really, really important to get up-to-date information out of the monolith. This kicks off a flurry of other tools. I've picked out a few of them here that I think are really significant to the culture of EVE. EVE Fitting Tool pops up at around about this point, hits the fitting metagame like a meteorite, dramatically lowers the barrier of entry to doing sort of large-scale fleet stuff, and also, I guess, small-scale, like small gang. Very shortly after that, the in-game browser is upgraded to Ausomium. That in itself, not really relevant to third-party development, but it represents a decision because the in-game browser headers have existed for a while at this point with our own internal hand-rolled browser engine, and the decision is made to keep them when we move to Ausomium. Shortly after that, Eve Killboard. This is actually when it was scraped by the Wayback Machine, which indicates that this is the point that people start chucking links for it all around the internet. This is now a centralized location for corporations and alliances to compare sort of how successful they are in wars. That sort of thing has a very big impact on the culture and on the politics of Eve. And then we end the timeline in January 2010 with a tool called Temar's Eve API, or T for short. That's probably one that not everyone has heard of. I've picked it because it's emblematic of a whole heap of separate and independent implementations. T is an authentication mechanism that allows you to tie access to TeamSpeak, the Simple Machine forums, and Jabber into your character's current corporation and roles. And that allows alliances and corporations in Eve to scale to the sizes that we see them today. So by the time we get to the end of this era, we're in a pretty interesting place. We've seen some amazing programs, and these are just 4 of them here that have defined the culture of EVE Online, but we've also got some key limitations. So one of them is that in order to make a, quote marks, fully featured EVE application, you have to know 3 totally independent and totally unrelated technologies: the headers, the XML API, and the static data export. And in addition to that, the largest and most useful source of data, the XML API, has no ability to write back to the game state. And to explain that to you, I'm going to give you a quick primer on exactly how the XML API works. So this is a diagram of the cluster. This inverted pyramid over here is Tranquility. Your game clients dispatch remote procedure calls to the proxies. So you might want to shoot someone, maybe shoot at a pod. You click the button in the client, it sends a remote procedure call to the proxy. The proxy is responsible for figuring out where that request needs to go so it ends up in the simulation that is simulating the solar system that you are in. You get routed to a sol node, and the sol node applies the game logic to decide what happened. You hit him, he died. The sol node does a bunch of different things at this point. One of the things it does is it writes the outcome of that fight to the database, and it also dispatches messages across the cluster to let other sol nodes that might be applying game logic elsewhere and need to know that that just happened, know that it has happened. So for example, there's probably a message dispatched to the sol node managing the station that he's about to appear in a fresh clone. The XML API ignores absolutely all of this and just goes straight to the database to ask questions. That's a really easy and really maintainable way to get information out of the monolith, but it means that you're in undefined behavior land if you try and write stuff back to the database. There's no way to know what the simulation will do if you do that, so we don't. So there's interest in solving this problem because at around about this time in our timeline, there are some interesting ideas about a potential new game floating around in CCP, and we need some kind of write access to the cluster that does not involve the EVE game clients in order to implement them. And so we end up here. This timeline's a bit more accurate, and there's a bunch of more stuff that could be on here, but I've cut it right down to what I consider to be the precedent-setting events during this period of third-party development. Actually, off the left end of this graph, it's a little bit of a historical note. There was an internal prototype for, not CREST at that time, but for a writable API that was based on remote procedure calls. The CREST development team made the case that that was basically not the right way to go about solving this problem. That case was accepted, and so towards the end of 2010, we see a whole bunch of testing and prototyping to see what that might look like. And by February 2011, we've got what is basically an architecture document describing what you would all recognize as CREST. A bunch of engineering work happens. I'm just going to gloss over absolutely all of that, and the next major step that we have is in December of the next year, CREST is released to third-party developers. And this is important because we've now actually got both CCP developers and third-party developers using the same API, and that's never happened before. Up until this point, it's been XML API for third-party developers, Matronet for CCP developers, and absolutely no crossover there. Now everyone's on the same set of tools. And it's rapidly followed by a second precedent, which is that on May 2013, we released Dust 514, and that means that CREST is now a production-grade service. It's in the critical path of a released product, and it is treated with the same respect as the Tranquility cluster itself. More endpoints kind of trickle out. CREST is increasingly developed over the next few years. And in November 2015, we get the first writable endpoint. This is the fittings endpoint. I think it's kind of surprising how quickly everyone's acclimatized to the concept of write endpoints, because it was actually a really long journey to go from the original concept of CREST through to its promise being made available to third-party developers. That kicks off a small avalanche of development. We see write endpoints for autopilots, for setting contacts, for a whole bunch of other things, and increasingly those write endpoints are targeted towards a specific area, which is functionality that was up until then only provided by the in-game browser. And we end up in a position in June 2016 where enough of that functionality is covered that we can retire the in-game browser. And that's important because we've taken one of the most sort of arcane pillars of EVE third-party development and we've moved it into a much saner location. So at this point, we've got sort of static data and dogma info in here as well. The static data export is getting less and less mandatory. It's a pretty good spot, and the story could end here, and this could have been the presentation of, and then nothing interesting happened for the next 12 months, but there's still a key limitation here. And to explain that limitation to you, I want to show you how CREST works. So we've got this same inverted pyramid structure here, but over on the left-hand side, we've got this green CREST proxy. Now, software-wise, a CREST proxy is actually no different from an ordinary proxy. It runs in the same cluster, it's running the same software. We have load balancers in front of it that make sure that remote procedure calls from the game clients go to the normal proxies and RESTful HTTP calls go to the CREST proxies. But that's there strictly to make sure that a large number of CREST calls can't damage the performance of the game clients. Otherwise, there's no real difference between the two. And there's a bunch of complexity in how CREST works, which I'm just going to gloss over, but at its very core, all it really is a translation layer. So it ingests RESTful HTTP calls, it maps them to internal matronet calls, and then it routes them to sol nodes exactly as if they were a call from a game client. That's a pretty well thought out system, but the limitation is that it's still within the EVE framework. So because this is a proxy, just like any other proxy, it goes down at downtime, just like any other proxy. It's bound to the same development cycle, it's bound to the same criticality, and it's a bit constraining to be in that area. So TechCo is keen, maybe not so much to escape as to transcend that limitation. And to explain to you exactly how we did that, I want to introduce CCP Snowden to the lectern.
Hello. You're all feeling good this morning? So this is the highest level overview that you'll ever see of ESI. It's contained in one bubble. It's basically the same as you saw with CREST, except what we've done is on every sol node, they pull from Google PubSub messages that ESI requests from that data source. So ESI gets to live out in Google Cloud land. It can talk to many different PubSubs, and PubSubs can talk to the cluster. This works really well for local development and everything also. So what I'm going to do is take all of this stuff, because we know what that is, and that's just going to go down into the corner. That's down there now. And we'll expand what ESI is actually doing. So you can see the request comes in. This is what it looked like on launch day, by the way. We're going to go through 3 iterations of this already. So on launch day, everything was pretty basic. Everything was Python. Requests would come in. They would go through the ESI router. It would find what endpoint that was supposed to be going to, or if it's to the Swagger UI. It would go into that endpoint. And then from there, if it had cache data, it would send it. If it didn't, there's a concept of data relay inside of EasyLib, which is how it talks to Google PubSub, and it waits for the return, which comes in through ESI replies. This was a push reply from the start because we noticed some limitations in the speed of pulls. It works really good on the sol nodes because we have so many sol nodes, but ESI only has one source of return. So to have that sitting on a pull is just not fast enough, but push was much better. This worked for a while. You can see some single points of failure in there. So we started to add some things. The first major one that you're going to like is the Google CDN. That makes your requests ridiculously fast if they are cached. The other thing is adding a Go router. So this basically just used the Python router, which was doing all of the Like the Python router is also talking to every endpoint, getting their specs, consolidating all these Swagger specs into one document. And then the Go router can talk to the Python router and figure out where all these things are in the data center and route the request appropriately. So that was nice speed up there. Otherwise, everything was mostly the same. And then shortly after, we changed the reply path as well to also be Golang, because that's another major source or single point of failure in the entire cluster. And then so from there, it goes into Go replies and then back into the particular endpoint. So I'm in the bottom right corner here if you can't see. It's Go replies into the ESI replies, which is actually the exact same container as that ESI endpoint. Uses a little inner process thing there because we were finding endpoints could get saturated and then the return path would not have an open connection for it. So now we have a dedicated return path. So inside of EasyLib, this is hopefully just going to be like a quick primer. Some of the stuff will probably change by the time we get around to actually hopefully open sourcing this. But this should give you a basic idea of what's going on inside of every endpoint. Requests come in through Grunicorn and stuff and through Flask. We validate it right away. We make sure there's JSON. There's a centralized caching for auth. So we have a lot of the same limitations that the SSO has. If you've cached with it, or if you've used a token before, it'll be valid for the life of that token. There's no way to invalidate it. So access tokens are valid for 20 minutes, but that's how it is. And then we prep the data relay, which is mostly just generating the caching key for the route. We actually check with the cache, which at this point is Cassandra. We do a little data source alive check, which you guys would probably see as the every once in a while that you get Tranquility is temporarily unavailable or something like that. That would be from there, because we don't actually get a response from the server that has gone down. And there's many different reasons that a server could not be responding to messages. It could have just shut off its driver, and it's not going to talk to ESI anymore. It has other things to do. The network could go down. Google PubSub could go down. GKE could go down. Who knows? And the other thing about ESI is it supports multiple data sources at the same time, including your local development server. So potentially, if you set it up. So it's maintaining these liveness checks kind of, or availability per data source there. And then we validate all responses. This is something that CREST tries to do on most endpoints, but not all. ESI actually does every single response that it sends to you is validated from the endpoint's spec for that return code has to match the spec that it says it is. And then the endpoint function gets called, which could do anything and return anything. And ESI just kind of deals with that. And there's arrows both ways because these are all wraps, and they get executed on the way in and the way out. Hopefully that made sense. We'll see. Here's something that's even more intense. This is the ESI development timeline that I threw together in R. You see the first...
It's actually clipped the dates off the bottom of your slide.
It did clip the dates. Oh, that's awful.
What's it running from month to month?
So at the start is just a little bit before July. The first white line, that you can't see at all, is, that's really unfortunate. So right at the end is April, obviously. Oh, you can tell. Yeah, it's right here. It's just really small. A little bit small. So yeah, at the start, it was just EasyLib, and then we used the upstream Swagger UI for the UI stuff because making UIs is not fun. It took about a month or two in proof of concept phase until we had something that kind of worked. And then at that point, it split out the rudder, which is the spec consolidation and everything else, and the scripts. That's when you see those repos come into existence. ESI Admin Auth, which I'll show you the admin interface in a little bit, was added. And then a lot of validation, Sentry, standardized caching. Actually, right at the start there, ESI Test. A lot of the standardization stuff comes from a script called ESI Test, which will verify all these repos that you see on top. It runs all of their tests, and it also runs the test for any endpoint. So if you go to make an endpoint for ESI, we have it set up in our CI, so when you check it in, ESI Test is automatically run against it, and it'll verify a lot of things like you have examples for stuff, you have good names for things, everything is well-defined in your spec. So that was a really key part to add as soon as possible because of how distributed this is and how many different repos there are now. Managing all without standardization would have been terrible. So anyways, getting back to that, just before October, which is that second little thing that you can't see, that's when the Swagger UI was finally themed, which everybody loves the theme, I'm told, every day. It's kind of a joke. But we've made it a lot faster now. There's not really any egregious problems with it anymore. Then we added Datadog support, and just before that, you see those two repos up top, ESI Replies and ESI Services. Then that's just before the public release. That's like 2 weeks before we went live with this. We had to kind of change our paradigm with how we were using Google PubSub. We had it set up so that each action, each thing that I'm requesting from the monolith was a topic, and then each requester of information had a reply topic. This worked really well on a small scale, but we quickly found that we were using way too many connections to Google and breaking all sorts of quotas and stuff, so we rearranged that all so that there's one topic that all of ESI will send to per data source, and then there's an attribute inside of that topic that tells them what that information is actually requesting, or what they're actually requesting. And then there's one reply topic to the entire cluster as well. And that was a couple weeks before release, and then we released. And then noticed that we had way too many Redises, and Redis was becoming way too centralized and important, which I don't like Redis being important. So we changed it to Cassandra, which has proper clustering, and the performance is just knocking Redis out of the park, so that was good. Shortly after that, we added PyPy, which ESI is still running PyPy 2 today. It can also run in Python 3, 5, and up. But that was another relatively major performance increase. Did some things with Cube, just changing to deployments and added the CDN there. And then we added ESI Services was its first use. You see it's been in existence for a while. ESI Services is actually how other ESI endpoints can address other endpoints to get data. So the first thing we made was an endpoint called ESI Access. And the first use of that was by ESI Markets to tell if you have access to get market data in a Citadel. So we use the Swagger spec and we use Bravado as a core component in ESI. Then a lot of work went into multiprocessing stuff, which is just more performance. The underscore routes, which are really great if you do version stuff and you want to know, you can do underscore latest / Swagger JSON, and then it'll give you a base path of / and the version will be in each route. So that's kind of nice if you need like an offline copy of the spec. That's not going to change on you. Then we got into 2 endpoint containers, which was kind of what I was talking about with the separate dedicated reply path. And then it's kind of cut off there, but our first open source endpoint, which was ESI Routes, that was actually a project that started last year at Fanfest. If you go to the GitHub page there, there's a README that shows or talks a little bit about the history there. But we're looking to open source more and more as we go. So what is ESI made of? These are all the bits. If you're a nerd, you might like this. So Python, we do a lot of stuff with Flask and gcloud, obviously. Unicorn gEvent is massive amounts of gEvent. Requests, Raven, Flashcache Cassandra, which is just, it's the normal Flashcache, except I added some Cassandra drivers in there. Inflect for some language fun times. And Bravado, like I said, to talk to other ESI endpoints. And then in Golang, we use Mox router for the Go router, and we use HTTP router for the replies. And then a couple other bits and pieces, as you see. So, how is ESI doing? Should we take a look at some live graphs? Do you think that'll be a good idea? Probably very little. Where's my browser? So, there's no way that this is going to go wrong. Uh-oh. One sec. One second. My alt tab's over there, isn't it? You. One sec. Yeah, last year we did a deployment, but it was kind of cheating. This year we're just going to actually do it live. Okay, here we go. Oh, hey, that's a good idea. Let's do that next time. Sweet. Okay. So yeah, you see our RPS is on the side there. This is all uncached, by the way. This is all behind the CDN. So that's our current RPS, our current endpoint average. Oh, hey, it is on that screen. Sweet. So you can follow this. Nice. Yeah. Basically, I mean, these are all the things you want to know, right? We're doing 42.5 million requests a day today. This is actually down quite a bit. We've released the character affiliations endpoint. So you can now, oh God. So you can now request 1,000 characters affiliations at a single request versus obviously 1,000 requests. So that's dropped us by quite a bit. Then we measure our average, and I like to measure the max of everything as well. Today's top routes, these are what people like. Oh, something must have happened there. Oh, yeah, it's downtime. There you go. Look at that. Yeah. So you'll actually probably be able to see that. But yeah, this is the RPS per endpoint. You can see the locations is pretty solid here. These are all the tripwire guys. And corporations and markets and stuff just kind of spikes as you go. All sorts of graphs. More graphs than you'd want to know. But yeah, we can tell basically top request per endpoint in the 10 minutes. There's errors in the 10 minutes. You can see who's generating errors. Messenger of truth right now, you're number one. GC runs, validation runs, timeouts, cache space, cluster memory, cluster CPU. This is per endpoint as well. John Cena. So yeah, action failed. So this would have been probably over downtime. Yeah. There's all the 503s. Yeah. So that is basically how we are monitoring things and what I look at most of the time. The other thing we can take a look at here, oh, maybe I shouldn't quite show you all that. Too late. I can show you the load balancer side of things in Google. So this will show you our CDN hits. Oh, why is my screen so small? Can I make that smaller? Oh God. Forward. Okay, cool. We did make it smaller. Change that to that. Okay, so this is the last hour. Our hit rate, that was downtime. You can see to the day. The blue line is the CDN hits. They're kind of spiky, but that's how it goes. Yeah, and we can see per area and per the cache hits per area and the usage. Go to a 30-day graph if you really want a whole bunch of history. That's what she looks like. Yeah, so that's pretty much gratuitous graphs. Now, in the carrying on the tradition of doing things live, let's live deploy some code.
This is the point where I start to ramble?
Yeah, you can now.
Microphone.
That mic should work.
Microphone might be on. Sounds? Excellent. Some of you might remember last year, we deployed a little web app called Ship Toasting. It was a very small little thing. It was basically just there so that we had something to deploy during the Kubernetes demonstration. But It went super well, it was super positive, and so we decided at the risk of possibly creating a tradition, we'll see, we'd bring it back this year with a little bit of a twist. So what you're about to see here is Adam is about to make a cube deployment to deploy the front end of ship toasting, and then he's going to deploy a brand new ESI endpoint that none of you have seen before, and that also, sorry, none of you have the scopes to access, that enables the mini game that we've plugged into it this year. So what's happening is that the Society of Conscious Thought has created 3 grades of medals for the Kyonoke Inquest. There are bronze, silver, and gold medals, and every day that you log in, you can have 3 of them that you can choose to grant at your discretion to other capsuleers. This medal will actually be delivered to them in-game, so there's a small little lasting result of this. And if 10 people give you a bronze medal, you will be given a silver medal that you can hand out to someone else. If 10 people give you a silver medal, you will get a gold one that you can hand out to someone else. So we'll see how this goes. We're kind of expecting the gold ones to be relatively rare. And it looks, Adam, like you've been cut off the Wi-Fi. Would you like a wireless access point? How you doing?
Yeah, if everyone could just get off the Wi-Fi right now.
Do you need an access point?
Yeah, we might have to. We do have a backup internet connection that we might have to switch to.
Yep. Please stand by.
This was the fear.
Yep. Let's go with that.
Oh. Oh. There you go. Come on. Overheat the hope. Anyways, normally this works right away and it's great. It worked right away every time when I tested it too. Yeah. Yeah.
Nothing can be too perfect. It'd be distressing for you all.
Yeah.
How are we going?
Yeah.
We might have to deploy this after the presentation. That is unfortunate. That's all right,
That is unfortunate.
Let's move on. So
sure.
we'll bring that up in the short period of time that we've got between this presentation and the roundtable in the next session.
Yeah, I'll show you guys what it is to deploy an ESI endpoint, though. This is really all it is. That's it. If I had internet access, that would have totally made an endpoint.
Yep.
You're just going to have to believe me. And I'll very quickly take you through the admin interface of ESI. Oh yeah, my internet doesn't work. Oh, this is really sad.
That's an interesting question. Has the amount of data that Datadog's pulled down has gotten you kicked off the Wi-Fi?
That'd be fun. Oh, yeah, that's a different error. Oh, it probably couldn't figure out what its config should have been. Yeah, I don't know. I don't know why I get a little bit of internet. Here's the admin page of ESI. Basically just tells you what our running versions are, what's available, all the endpoints that are available, where they're running, what versions they have, what data sources are backing them. So that's all the endpoints there. What services are available. This is ESI Access that I was talking about. What routers currently we're just running to. What SSOs are available. This is kind of where you get into the local dev thing. So if you had a server running on your desktop or something, you can just plug in a data source for it and give it an SSO URL. If you want to jump on the back of TQ, you can. If you don't, whatever. Or if you're doing SSO dev and you want to jump on the back of TQ data, you can do that. You can mix and match. And then, yeah, just a little summary in my headers. No big deal. And that's about all there is to that. Let's see what's happening in the presentation now. Yeah. That would have been fun. We will get it up though, and it'll be running for a couple days, and definitely do check it out. Ship Syntax CCPIS will be live in like as soon as I get internet.
Right, so I want to cover a little bit about what our immediate plans are for the next, well, approximately 13 months. So we released the Introducing ESI dev blog in November last year. Do a little bit of maths, you get 13. And we said in that dev blog that we were targeting 18 months to the shutdown of the XML API and CREST. So yeah, we've got about 13 months remaining. We feel that we're on track to achieve that without causing you guys any undue pain. So we're actually already at parity with CREST, with the exception of the tournament endpoints, which are part of a longer term plan that I don't have anything to tell you guys about today, but we'll see how that goes. Everyone got on board with ESI issues super quickly. I'm really happy about that. I know that there's a bunch of feature requests on there because everyone's super keen. We're not ignoring them, but I want you guys to know that particularly in the last couple of months, we've been laser focused on trying to hit parity with all the existing APIs. So if you've got a feature request open, particularly for something that's already in the XML API or CREST, and it's not been addressed, don't stress about it. It is on the list, even if we haven't commented about it. Yeah, we are going to start analyzing our traffic very closely and keeping a very close eye on user agents, and we're going to be looking for significant outliers that we can reach out to and assist with this transition. We're going to push really hard to get everyone moved over to ESI because the maintenance burden for the XML API and CREST is quite a boat anchor on the team at the moment. So barring an apocalypse, this date is probably not going to shift further away. But to give you some idea of usage, at the moment, on a good day, all three of the APIs are collectively serving about 200 million requests. As you saw from Snowden's graphs, it's about 40 million-ish on ESI. It's actually a 40-40-20% split between the XML API, CREST, and ESI. And we're expecting to see a bunch of those ratios start shifting as time goes on. So it depends a lot on how much they shift, but there's a possibility that if those numbers, particularly for the XML API, drop as low as sort of maybe 3 to 5 million requests a day, this date might be moved forward. It depends a lot on exactly how the transition goes. Oh, that's not quite where that text is supposed to be. RIP. But before we take questions, I want to make sure that everyone knows how to contact us so that they can talk about all of this sort of stuff. The very best place to contact us is the TweetFleet Slack. So that's tweetfleet.slack.com. Most of the team is in the #ESI and #DevFleet channels. Due to a complexity on how Slack allows people to open accounts, it's difficult to get an account on there, but Fuzzy Steve, who is a national treasure, runs a website where you can go and sign up. So if you do a Google search for Fuzzy Steve TweetFleet Slack, you'll find a website where you can get an account set up for that. Yep. So I might just repeat that for the YouTube stream. So that process is still manual on the back end. So if it takes a little while for you to get processed, don't stress about that. It is happening. So the #ESI channel in particular is where we broadcast status updates, particularly if there's outages, either planned or unplanned. And it's also where we discuss with the ESI community about how the endpoints are getting structured, things like cache timers, schemas, that sort of thing. So if you want to get involved in how ESI is being developed, or if you're running something that you consider to be operations critical, you definitely should be in that channel because that's where you get all the information. I briefly mentioned ESI issues. That URL is just completely obliterated on the screen, but I think it's github.com/ccpgames/ESI-issues. That is where we have a ticketing system for bugs and feature requests. It is definitely the right place to go if you would like to see a feature in ESI, although I would like to say it's not the right place for SSO, static data export, or XML API stuff. But if you've got a feature request or if you've got a bug in ESI, please go and file a ticket there. It's a fantastic resource for it. We're basically grinding through it as we finish one task. We go back to ESI issues and look to see what other tasks are on the agenda. You will also find on that GitHub project a deployment status page. That is where we broadcast breaking changes to the API. There's a blog up on the third-party developer's website that explains how to use versioned routes to make sure that that doesn't bite you in the ass. But we also publish when we're going to release new versions of endpoints so that you can see what's happening. So yeah, if you want to contact us, Tweet Fleet Slack or Easy Issues. Snowden has also asked me to spruik his Twitter at ccp_Snowden. He also does, he also does status updates there and stats and other little pieces of interesting information about ESI. So feel free to follow him on Twitter. So with that, if anyone's got any questions, we're probably actually going to have to pass one of these mics down to someone because I don't think we've got any set up on the floor. So CCP Chimichanga has the microphone. Please feel free to step up to the front and ask a question. Also bear in mind there's going to be a round table in JITA in the next session, so if you guys have got long or in-depth questions, it might be a good idea to save them until then.
Hi. Could you give us a quick run-through of how it would work with OAuth and with ESI, doing, like, say, core applications and background checks? Like currently, we need a full API key. We can check this see if it's a full API key, et cetera, et cetera, et cetera.
Yep.
How does that work under the ESI system?
So that might actually be a question that I pass to CCP Chimichanga, who's right next to you if you let him steal the microphone.
So this is one of the main things that we've been looking at. Basically, the API keys is not something that we want to have for ESI for a lot of different reasons. And we haven't found a good reason to have that. Ultimately, API keys are a multi-user system. And that's not how the APIs are designed, but that's how they're being used. We've been talking a lot internally about OAuth workflows. There's some things that a lot of OAuth workflows do where they will drop out basically give you a URL, you'll put that URL into a website, that'll give you a token, you drop in the token, and then you're off to the races. As far as when it comes to things like how much access do you have and what scopes you have access to, these are other things that we're working with the SSO team because we'd like to get JWTs set up and actually be able to unpack useful information in the tokens themselves. So that's coming a little bit further down the line as well. Does that answer your question? Yes, it's on the list.
Yep. Yep, you got one down here.
Hello.
Hi.
I have a question about the OAuth token. When we use this token, it is intended to keep them a long time and use the refresh token to get them back active. Or we must create a new token each time?
Yes, so the access tokens expire every 20 minutes, and it depends a little bit on what workflow you're using. So if you're running a website where you've got a private backend, then yes, the intention is that you use refresh tokens and that you periodically request new access tokens using your refresh token. If you're running like a desktop-based application, there's a different kind of flow called the OAuth implicit flow, which allows you to request access tokens without having to ship your secret key with the application. But the downside of that is it means that you don't get refresh tokens, which is what you see in Python. So you usually have to log into Python every time you use it, unless you shut it down and fire it back up within 20 minutes. That might work. So yeah, it depends on what kind of application you're running as to what kind of flow you want to use.
In a website, if we create an account, we can keep the refresh token every time, and it will never expire.
You would typically keep the refresh token and you would use the access token temporarily. It's kind of up to you as to how long you want to cache it for. Like, it depends on the traffic that's on your website. But you would use the refresh tokens as your primary mechanism of getting new tokens.
Okay, thanks.
Is there any plan to allow the third-party developers to terminate refresh tokens? Because currently only the users can go and do that. They have to go into this certain page and find their tokens and then terminate them that way. Is there any possibility of allowing third-party developers to say, okay, I'm done with this user. Let me just, for security reasons, let me just terminate that refresh token?
I'm going to give that one a solid maybe. So I have a bunch of plans for exactly how we allow users to get rid of their tokens. At the moment, it's a little bit of an arcane process. So I want everyone to know, by the way, you can go to community.eveonline.com/SSO, and that'll bring you to the page where you can delete them. But this is not very visible. It's not very easy for people to find it, and lots of characters don't know about it, so they never revoke their tokens under any circumstances. I'm working with other teams to see if we can make a better web page, maybe even embedded in the launcher, although I can't promise that. And as part of that process, we need to make endpoints which do allow people to, or at least allow us to delete tokens on people's behalf. So I can certainly look into the possibility of making that a more general access that third-party developers can use, at least specifically for their tokens. Yep.
Any other questions? Oh.
You previously talked about stream APIs, where you can stream data from the client. Is there any timelines on that?
There's no timeline on it right now because there's not a good way to mix streams with the current Google Layer 7 load balancing. What we would have to do is deploy it under a different domain. So it'd be like Easy Streams or something. And then it would have to, you can't describe a spec that spans multiple hosts either, so there would have to be a separate spec for streams as well. It's something we're looking into, but I hope to get to it sometime. But I'm not willing to commit to any sort of timeline on that. I really want it though, especially for kill mails and location. I'm looking out on you guys.
Anybody else? Right, I think that's it. Thanks, guys.
Cool. Thanks for attending, everyone.